All right, I'm recording and sharing screen. So I spent 3 hours last night trying to solve that problem that we did yesterday using nodal analysis. And I ran into the same roadblock I ran into last year. And then I realized it was like, oh, this is like deja vu. Now I realized what went wrong. So what I did was, and I'll explain this later, but what I did was I found another circuit, and I did find in my notes from last year, I did the same thing. I basically took a simpler circuit with one node. So what we'll do is we'll do this circuit, and this is actually homework 4. And I was reading my notes. Here's what I did. Let's find my notes. I'll read it to you. I spent a couple of hours this morning working on the nodal analysis of the DC circuit we did superposition analysis on and found I was doing something wrong. And I'll explain that later because it won't make sense until you understand what nodal analysis is. And then in my notes, I said I had to cut my losses because I spent so much time on it. And then I had to find another circuit. So what I did was I said, to compensate for not providing a one-to-one comparison of superposition with the circuit we did yesterday and nodal with the same circuit, and then show that we get the same answer. For the compensation is I'm going to do the problem from homework 4.
Yeah.
So if all you have to do is take out if anybody wants, I can print out homework 4 and give it to you. And then you can take notes, and then you have the answer. And then you can just finish homework 4 and turn it in. Then you're done with homework 4. So let me know. Let's go through this circuit. So let's do this first, and then I'll print out homework 4 and I'll print out the worksheet. So this is what we're going to do. We're going to do superposition with this circuit from homework 4. Then we're going to do nodal, and we'll see that they're both the same.
Okay.
And I'll say plus multisim. Question? What?
Yeah,
Homework 4 is nodal analysis.
that's why we're doing both.
Well, let's look at it. So I believe it's the same circuit. So it's 10, 20, 8, 4. Okay, now let's look at 4. Ten, 20, 8, 4. It's the same circuit. So actually, I've given you homework 3 and 4. Not just homework 4, but homework 3 and homework 4. But let's do the circuit. So nodal. Then I'll show you. Then I'll explain to you what I did wrong on this. Why I actually did end up getting an answer, but I'll show you what happened. I figured it out this morning. I started at 4 o'clock in the morning. I worked on it for like 2 hours. I finally figured it out. Or no, last night I did it. I did it before I went to sleep, and I couldn't stand it anymore, and I just went to sleep. And then we'll talk about the take-home exam. And then we're going to look at what I did when I was a student. I might have to run to my office. Then we'll go over worksheet 1. Worksheet 1 is like an in-class activity. And then if we have time, we'll finish lab 1. All right, so let's get this going. Okay, so this is where we are. Remember I said I'm going to push this till next week. AC, nodal AC, I'll push this to next week. and lab two. I'll update this over the weekend. I haven't had time. So we're doing this right now. All right. One reason I opened that is because I want to know what lecture this is. It's lecture 8. Not this. How do I turn that off? So I'm going to turn it off. I push something on the stylus. Push the button or something. I'll call it superposition versus nodal. All right, so here's the circuit. Like I said, this circuit is in homework 4 and 3 and 4. In the interest of expediency, I'm just going to write the numbers down. So I'm going to copy this so I don't have to keep redrawing it. That should be. So here's mission find. Here's VAB from there to there. Find VAB. So step 1, I'll do it in red. So you can redraw the circuit, or I don't want it. I want to fit everything for the first part on this page. So I'm just going to do this. So when I redraw the circuit, that's what I do. Just so you know that there was a power supply there. We need to find this current. So RT is, and I'm not going to write the formula for total resistance. You guys should know that by now. I'm just going to write it. It's 10 plus 20 in parallel with 11. Do you see it? And I put it in my calculator and I got 7.097 ohms. or no, REQ is 20 in parallel with 11. And that is 7.097 ohms. So this is 17.97. IT is 30 divided by 17.1. I'm just going to round it off. And that's 1.754 amps. I'm just writing this down because these are just simple scalars. You know what I mean? You guys should be able to punch this in your calculator. And then we'll call this IAB prime. IAB prime is IT times REQ divided by 20. So that's going to be 1.754 amps times 7.097 divided by 20. And I got 0.622 amps. And again, like I said, you can write this. What I would do is I would write it in my notes and then look at your notes and you can do the homework. All you have to do is copy it to the homework sheet. I'll print them out for you. So it's homework 4 and 5. I'll print them out and give them to you. And then VAB prime is IAB prime times R2. It's going to be 622 amps times 20 ohms. And I got 12.45 volts. So that's half the problem. You know, I just thought of something. I don't think it's going to let me erase. Yeah, I'll just write over it. Because I think I tried to erase on that thing I pasted in one of the lectures and it wouldn't let me. So is everyone with me so far? Let's just try it, see what it does. Yeah, it won't let me. So I'll just write over it. Let's see if I can write over it. So now we replace the other power supply. And now RT is 3 plus 8 plus 20 in parallel with 10. REQ. What the hell happened there? REQ is 20 in parallel with 10. It's 6.67 ohms. So this equals 17.67 ohms. IT, I suppose we could call this prime, double prime, so we don't mix them up, is 18, our power supply, divided by RT, which is 17.67, and that's 1.019 amps. And then IAB double prime is IT double prime REQ divided by 20. So So that's going to be 1.019 amps times 6.67 divided by 20. And then I got 0.3397 amps. So VAB double prime is IAB double prime times R2, 0.3397 amps times 20 is 6.793 volts. So now we have our two, so we have 12.45. Our VAB will be VAB prime plus VAB double prime. VAB prime is 12.45. And VAB double prime is 6.793. So that's going to give us 19.24 volts. Okay, so now I might have to redraw this because I have to write on it. It's not going to, well, maybe, no, I can write on it, I guess. I can write on it. I just can't erase. So does everyone have this so far? So now we'll do nodal. It's the same circuit, nodal analysis DC. Step number 1. Identify non-trivial nodes and reference node. Non-trivial nodes means there's more than one connection or more than two connections to it. More than one connection. So this right here is a trivial node. There's two components that are connected together. So here's a node, node 1, and here's the reference node. Step 2, indicate currents and polarities. So here's your polarities of your power supplies. There's I1. And you'll see later that it doesn't matter which direction you draw the arrows as long as they're consistent. This is plus minus. I2 is this way. I tell students, draw them where they logically would go. Some current comes out of this power supply, goes this way. Some current goes here. Some current comes out of here and it goes this way. That's I3. There's our polarity. Here's our polarity and our polarity. So you can look at it this way. I remember I used to get confused about those polarities. So you're standing at the positive terminal of the power supply, you walk away from it. What's going to happen when the current goes from here through here? It's going to drop a voltage, right? So it's going to be plus minus. We go here, some current goes into this branch. What's going to happen? It's going to drop a voltage across this resistor. So it's going to go plus minus. And then you can draw, you can think of some current comes out of this supply, it drops some across there and some across there. So be consistent with your with your polarities and your directions of the current flow. The one time that I don't mute this and it starts going off. And you'll see later that, let's see here. Man, that person really wants to call me. You'll see later that if you flip the signs around or if you draw the arrows differently, it'll still come out right. And I'll show you why. So that was step 2. Step 3. Right? Kirchhoff's current law equation. I'll put S in parentheses. If you only have one node, you're only going to have one equation, right? So let's write it over here, or we can write it right here. So here's our node. What's coming into our node? We have a plus I1. Look at it, it's coming in. If it's leaving, it's minus. Plus I1 minus I2. I2 is leaving. Plus I3 equals 0. That's Kirchhoff's current law. The sum of the nodes, or the sum of the currents entering and leaving a node equals 0. Step 4. Write KVL equations for each branch. So I have a branch here. I have a branch. Some current goes through here and it comes through here, comes back. So that'll be number 1. So what do I have? I have a voltage rise. Look at minus to plus. That's a rise. Plus V1. Always write plus or minus in front of each component of the equation. It might seem redundant to write a plus in front of something, but you'll see later that if you don't, you'll make a mistake. I should say in parentheses, in terms of I's. I'm just going to say I's in terms of branch currents. I'll just say in terms of I's. So how do we express this voltage in terms of I? It's a drop, plus to minus. It's a drop, so it's minus I1 R1. V equals I times R, right? That's sometimes you'll hear the expression an IR drop, a voltage drop, an IR drop. Like over transmission lines. Like if you have a real long cable extension cord and it gets hot, it's because there's an IR drop. Because there's current going through this piece of wire that has some resistance. Like if you have a really long cable and it gets hot, that's why it's getting hot. Because it's dropping some voltage across there, which is creating then it's dissipating power, right? Because there's current and there's voltage. So there's power being dissipated across your extension cord. That's an IR drop.
Kind of feedback loop. Once it gets hot, it starts dropping more power.
Right, because then the R goes up.
Resistance goes up, yeah.
R goes up and then it gets hotter. It's right, it's positive feedback loop. And then what's the last one? Oh, I'm sorry. This is we'll call this point A and this point B. And this is VAB. I forgot to write that for you. So we're gonna do plus to minus is a drop minus VAB equals 0. That's Kirchhoff's voltage law. The sum of the voltages around a closed loop equals 0. Kirchhoff's voltage law. And do you see where we're going with this? We want to find VAB. So we're going to end up with an equation. We're going to solve for VAB. Number these equations. So the number 2, well, here's a branch right here. There's a branch here. Oh, look, here's another branch. What is it? We're going to do a rise. We're going to go from negative to positive plus VAB. And then we're going to come back down and we're going to go back through here and we're going to have a drop. Minus I2R2 equals 0. You have to account for every branch. And then the last one is over here. Here's a branch. So that's number 3. So we have a rise right here, minus the plus V2, minus I3R4, minus I3R3, minus VAB equals 0. So we went from here to here, from here to here, and from here to here. We just went around in a loop. So what I'll do is I'm going to copy this to the next page so I don't have to rewrite it. If I can fit it right here. Can I fit here? Just barely. Yeah, I wonder if I can delete this. Not that way. Delete this. Edit. Why can't I hit the escape key and have this go away? There. Now Let's see if I can erase it. Maybe. Can I erase it at least? No, I can't. All right, well, let's just continue on. I'll waste so much time on this. Float around with this. So you have this in your notes. You have this, right? In your notes.
Yep.
I mean, all these things that I wrote in here. The stuff that we're going to do now is with this equation. Okay, so the next thing that we have to do is step 5. So this was step 4. Step 5. Substitute known values. And solve for i's. Solve for currents. I'm just going to say solve for i's because that's a variable that we're going to solve for. So what about equation 1? What do we know? We know what V1 is. It's 30 volts plus 30. Make sure you put pluses. Minus I1, we don't know what it is. We know what R1 is. It's 10. Minus VAB, we don't know what VAB is, equals 0. So what are we going to have? We're going to have minus I1 10 equals VAB minus 30. I1 equals minus VAB plus 30 divided by 10. You see what I did? All I did was solve for I1. Equation number 2. We don't know VAB. We know R2, I2. R2 is 20 equals 0. So I2 is VAB divided by 20. Equation number 3. We know V2 is 18. I3. R4 is 3 minus I3. R3. R3 is 8 minus VAB equals 0. So now we can solve for I3. So I got minus I3, 11. This is just algebra. It looks strange because the coefficient is after the variable. It looks kind of strange. I'm leaving it that way because otherwise it's messy and it's confusing. I'm leaving the coefficient here instead of putting it here. In algebra, the coefficient is in front of the variable. So it looks kind of funky, but just roll with it. So we got minus 11 I3. And if we move this to the other side, we got VAB minus 18. Now we divide by negative 11. So I3 is negative VAB plus 18 divided by 11. And this is if you make a mistake and you end up with the wrong answer and something doesn't work out, or you end up at a dead end, it's because you flipped one of the signs around. Now do you see what I mean about you can draw those arrows any way you want? Because the directions of the arrows is going to determine this sign. And it's going to determine the Kirchhoff current law equation. I had a student, he just wanted to be different, or he wanted to be difficult. And when I told him that, he said, "Oh, I'm going to have all the arrows going right into the node." Where is it? Here. I'm just going to point up all into the node. It'll be I1 plus I2 plus I3 equals 0. And he got the right answer. You know what I mean? He just drew all the arrows pointing at the node. So it's I1 plus I2 plus I3 equals 0. And he got the right answer. Because the direction of the arrow determines this right here. All right, so let's go back here. So now we have these equations. Now what do? Step 6, we substitute these I's, these currents, we substitute that into our KCL equation. So let's go to another page. This page is just going to be a blank page. It's not going to have the circuit anymore. So step 6. Substitute I's into KCL. So remember, KCL is I1 plus I1 minus I2 plus I3 equals 0. So here's our I1 right here. Minus VAB plus 30 divided by 10. Minus VAB plus 30 divided by 10. Parentheses. What's I2? It's VAB divided by 20. Minus, put parentheses around stuff so you don't mess the signs up. And then the last one, plus minus VAB plus 18 divided by 11, minus VAB plus 18 divided by 11 equals 0. Okay, so now let's just finish the problem and then I'll comment on this problem. So the way that we solve this is we separate out these compound fractions. So we have minus VAB divided by 10 plus 30 divided by 10. Do you see it? Minus VAB divided by 20 plus, or it's going to be minus VAB divided by 11 plus 18 divided by 11 equals 0. So if you punch this in your calculator, you get minus 0.1 VAB plus 3 minus 0.05 VAB minus 0.091 VAB plus 4.36 or 636 0. And then you have, if you combined all your VABs, again, this problem is very simple because there's only one variable. I think next week I'll show you an example of a DC nodal before we do AC nodal. I'll show you an example of one with two nodes where you have a system of equations.
Why do you have 4.636?
That's 18 divided by 11. The hell did I do here? Oh, I know what I did.
Oh, that's just the answer for.
Yeah. That's 3 plus 18 divided by 11. Sorry. Okay, so if you combine all your VABs, you get minus 241.241 VAB plus 4.636 equals 0. VAB equals minus 4.636 divided by minus 0.241. VAB equals 19.24 volts. So we got the same answer. So that's homework 3 and homework 4. I'll print them out if you guys want hard copies. So this did that. This did this. Oh. Just to give you a warm fuzzy, you can build the circuit. And you could measure it in multi-sim. Like I said, if you try to do an AC circuit for some reason it acts weird, I'm gonna have to figure that out. So if you run this, you get 19.24. So that's I built the circuit multi-sim and I got the same answer. Okay, so now let's look at what happens. I think maybe what I might do is you may have to do this. So I can like explain this. Everyone see this? There. So what I did was I drew the circuit from yesterday. And I don't know if anyone can see the mistake I made right out of the gate. This is I called this a node. I called this a node and this a node. It's actually the same node. And I got these sets of equations. And eventually I whittled this down, got to here. Let's see what I ended up with. 0 equals 0. And the same thing happened to me last year. I did this last year and the same thing happened to me. And then I forgot about it. And then now I did the problem again. And it's like, the hell's going on here? And I was like, oh yeah, this happened to me last year when I tried to solve this one. And then I looked at my notes and I even figured it out last year because I couldn't figure out well, how come it didn't work? It's because there's only one unknown. There's not two unknowns. There's only one. Because, like I said, this right here is not two nodes. It's only one node. So then what I said was, well, if VA equals VB, because it's the same node, right? VA and VB is the same thing. Look at it. Look at it. If I put a meter here and measure the voltage, and then I put a meter here and measure voltage, I'm going to get the same voltage. So VA equals VB. So then I said, well, then I can just substitute. I can just call this VA and add these together and solve. And I got this. It's not exact, but it's pretty damn close to what we had yesterday. Look at, we had I was happy that I got something. Where is it? Well, I think we had 3.56 or something like that. Oh, it might be in here. Superposition. Right here. .85. 3.65. So you could be attributed to a rounding error. So I did figure it out. The moral to the story is maybe next week on Tuesday, we'll do another problem, except this time, because this really this problem bothers me. But this time what we'll do is we'll put a resistor right here. And then we'll have two nodes. Because I don't want the homework and the take-home tests are just a single node. I'm not going to make it so ridiculously hard, but I want you to see one with two nodes. I want you to see one with a system of equations, because that's what we're going to do when we do an AC problem. So are you following?
I'm trying to figure out how the two junctions, they have something between them to be two nodes, separate nodes.
Yeah, because look at, if I put a meter here and measure, and then I put a meter here and measure, if there's a resistor there, those voltages will be different. If there's a resistor there, or if there's no resistor there, if I take my meter and go like this, I can move it here, 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 and I can move this here, 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 here. It doesn't matter because it's a copper wire, right? I'm measuring the same voltage. But anyways, I want, before we do nodal AC, I want you to see a problem where we have a system of equations, where we have two unknowns. And I also want to show you how to put that in, use the solver in the TI-89. There's a solver in the TI-89 for linear system of equations, for simultaneous equations. So I'll give you a little math lesson about simultaneous equations just to refresh your memory. Hopefully everyone's had that in like advanced algebra, or you've taken an algebra class in high school, or you took a class here, an algebra class, advanced algebra, algebra 2, whatever, pre-calc or college algebra. So if you guys hopefully here, let's go back to this. Hopefully you've seen like x plus 3y equals 5, 2x plus 5y equals 7.
Yeah.
So you have two unknowns, then you go like this, and you can add them, or you can use substitution. So basically, the reason you can do that is because these are both lines. As long as those lines intersect, there's a point that'll solve both equations. That's what you're doing, is you're finding the intersection point. I'll show you an example on Tuesday. Because I want you to at least see how to put simultaneous equations in the solver, scalars and complex numbers. It's so complicated putting complex numbers into the solver, because it's so easy to make a mistake. You have to like very, very methodically type it in your calculator. The reason I want you to see that is I want you to see how tedious it is, and then compare that to using a MATLAB script. In MATLAB, you don't have to set up the equations. You just put those I equations that we came up with. You just type those in and it figures it out for you. That's what Strangeway is going to do. He's going to do that, a nodal analysis problem with an AC circuit. And he's going to show you how to set the equations up. And then he's going to show you how to enter it into MATLAB into a script. That's what he's going to do on the 23rd. So, and I want you guys to at least know what the hell's going on.
Mhm.
Otherwise, you're just going to be sitting there and you're just going to be watching them. And you're going to be deer in headlights. And I apologize that the pace of this class, it is what it is. I did move power and AC circuits, AC power. I did move it after this. And that's why Owen discovered that there was a homework assignment, a reading homework assignment that is actually supposed to be in week 5. And I had it in week 2 because that was power. That was power, AC power. And we're going to do that in week 5. So that's what I have. That's what happened with this problem. We did that. I'll check that off. Oh, we're doing really good for time.
Yeah, that Nodal is actually a lot quicker than superposition.
Yeah. I think that's pretty much-
Yeah. So that you could see, at first you might look at it and say, well, how does that save me any time? It almost took the same amount of time. What if there was 2 nodes or 3 nodes or 4 nodes? And what you can do with that is you can program it into software and it'll solve your. That's what MATLAB is doing. MATLAB uses nodal analysis and it uses matrices. So what I'll do is I'll print out. I have to set up electrode. I'll print out worksheet 2 or worksheet 1, homework 3 or homework 4, homework 5, and I'll give them all to you. Yeah. Do you already have it printed out or 3 and 4? Is it 3 and 4?
Yeah,
Yeah,
3 and 4.
Position 4 is total.
Let me know when you're good, Ethan. You good? All right. So let me
Could I ask something?
here. Let me just give me 1 second. Let me here. I'm gonna do this. So let's take a break. I'm gonna pause this. I have to print all that stuff out, but I have to add a printer. So let me go. We'll take a break. How do I get back? Oh, it's right here. So I'm gonna. All right, I'm recording again. All right, I'm just showing you this for a couple of reasons, I guess. One of them is mainly because I'm giving you a midterm test take home. So you're gonna have an in-class test.
Yep.
And then I'll give you the take home part. And I believe, well, let's look at the schedule, but I believe the midterm test is on a Thursday. So then the take home would be due on the following Tuesday. So you have the weekend to work on it. The reason I'm showing you this is because the problem I'm giving you is a single node problem. And I think I ask you to do superposition and then nodal and show that you get the same answer. And it's an AC circuit.
We studied mesh this class?
No.
Oh,
And that's another reason I'm showing this to you.
Oh, well, AC nodal then is that based up against Ckts.
So we'll talk about nodal next week, or nodal AC next week. All right, so this is what I had to do. I had to do superposition, mesh. Mesh analysis is basically instead of using Kirchhoff's current law and then finding the voltages in the branches, it's just the opposite. You're finding the currents in loops. So if you look here, let's look at my. So that's superposition. Right here is mesh. You see you have loops. I was told by Strangeway that they don't teach mesh anywhere anymore. So the first year I was in this program, I taught mesh. We went through mesh and then I had the students, I gave them homework. And then after Strangeway said that, I said, well, then I guess I don't need to teach mesh anymore. He said, yeah, just teach superposition and nodal. And that's what he told me. This bridge course is kind of dictated by the outcomes that Milwaukee School of Engineering came up with the outcomes. So I that's what mesh is. So it's kind of the opposite. You're looking at loops, current loops. And then here's nodal. Okay, so I had to do superposition, mesh, nodal, and multisim of that circuit. And I had to do superposition, mesh, nodal, and multisim of that circuit. So remember I told you that, and I don't remember that my handwriting was this tiny. Maybe it's because I'm old. I can't see very good. I don't write real tiny like this anymore. But you can see how much work went into this. And all you have is one problem. You just have one circuit. It's a single node AC. So you're going to do superposition and nodal analysis. Yeah, and then here's what I had to do. Okay, so you can do this, but you can't use a meter. You have to use a scope. You can't use the meter. It doesn't work. The RMS meter does not work. Yeah, it doesn't work. You have to use the scope. Yeah, so like I said, let's look at the schedule real quick. So we'll review on the AT. Maybe what I'll do is we'll review on this day, and then we'll have the test on that day. Or maybe the test will still be on, maybe we'll just leave the schedule the way it is. And then I have it scheduled for the 30th, Tuesday. So maybe I'll give you the take home part on Thursday, the 25th, and then it's due on the 30th. the take-home part, and then the in-class test will be on the 30th.
No, that's,
So yeah, let's do that, because I want you guys to have a weekend to work on it.
then it'd be good practice for it.
Yeah, and then the in-person test, there won't be any analysis problems. There'll just be like a series parallel circuit that you gotta find the voltage somewhere. And then there's conceptual questions. I'll review before that test. Like I said, I put it in the schedule review right here.
Yep.
So I'm devoting half of this 3-hour class period I'm devoting to reviewing. So this will be a lecture, and this will be I'm calling it a lecture 18. So that'll be fine for that. All right, so we talked about, we did this. We did this. So let's do the worksheet. So what I should have printed out one for myself. So let's look at it. So I need homework, or I need worksheet. It's in, I think it's in here. It's in here. Worksheet 1 right here. So basically, you want to find the voltages across each one. L1, L2, C1, R2. L1, L2, C1, R2. R1, R1. Okay, so let me draw this. So good. So there's 2 inductors, a capacitor, a resistor. Two inductors, capacitor, and a resistor. $50, $100, $50, $100. Minus J60, 75. Make sure I'm not missing something. 50 volts, 60 hertz, 0. So it's 50, 0, 60 hertz. 50, 0, 60 hertz. Yeah, because right, because we're given, but it's 50, 0 degrees, 60 hertz. This is L1, L2, C1, R1. So we need to find the voltage across each component. So the way I would go about it is you could use voltage divider. I would prefer to find the total current. Yeah, that's what I would do. The point behind this exercise is I want you all to practice putting this into your calculators. So I'm going to be, I don't have the answer. I don't have an answer sheet.
Oh, I was going through it. I found what I did wrong. I put 10 volts instead of 50. When I was doing
Oh,
calculation.
yeah.
Because I got confused.
That'll get you. So you see the first one, it says find the voltage drops. And then step 2, it says prove that KVL holds true for AC phasor voltage by adding the magnitudes of the voltages calculated. I should reword this. By adding the phasors of the voltages calculated. Because you have to add, or by adding the complex No, I think I wanted it that way. You'll see in a minute. Here, I'm gonna add this. What must you do? So add this. If not, what must you do to get the voltages to equal the source voltage? So add that to the mix. First of all, let's do this. So what is ZT?
I got 17.154.
Plus XLT or plus JXLT minus JXCT. So that's going to be 75 plus J150 minus J60. That's 75 plus J90. Did you get that?
I just rounded out. Or,
Yeah, I got 50.194.
I just
Yeah.
decimal places.
Okay, so now find IT. It's 50 angle 0 divided by, put this in our calculator as Z. Store Z. Again, on a test, you can do this, what I'm doing right here. So you get this, you punch this in your calculator and it shows you that. Doesn't say store Z, enter. Then in the next step, just write Z with a circle around it. You don't have to write it out again. Because you won't have time for that on a test. So we're going to say 50 angle 0 divided by Z, enter. I got 0.427 angle minus 50.2 degrees amps. So now we should be able to find VL1, VL2, VC1, and VR1. Complex Ohm's law, V equals I times Z. So VL1 equals, oh, store this as X. Store X. I use X and Z because they're right here. You don't have to go alpha, and then hit the letter. Oh, you have a TI-89, so you know what I'm talking about, right?
TI inspired, but same thing.
Yeah. So we got J50X, J100X minus J60X and 75X. So we go parentheses 50I parentheses times X. 21.34 angle 39.8 degrees volts. 100 I times X. 42.68 angle 39.8 degrees volts. Minus 60 I times X. 25.61 angle minus 140.2 degrees volts. Last but not least, 75 times X. 32 angle minus 50.2 degrees volts. Okay, add up the magnitudes. So in the question it says add the magnitudes. So that's going to be 21.34 plus 42.68 plus 25.61 plus 32 equals 121.63. So what gives? Why do I have 121.63 when my source is only 50 volts?
Between the inductors and capacitors, they're holding on to different amounts of charge out of phase.
Because these are phasers, right?
Yeah.
When I think I was showing here, maybe I'll write this on the board. If I have, let's say I'm adding VL2 and VC1. VL2 is 4239 degrees. (42.68), 39.8 degrees. And I'm adding to that, I'm going to add 25.61 minus 140. Minus 140 is, there's 90, it's about over here somewhere.
Yeah.
I have to take into account these angles when you add. So there is a way to do that by hand, and here's what it is. Remember I told you you can draw parallelograms?
Yep.
Right here it is. If I want to add two phasers, what I do is I take one phaser, I draw a line parallel to the other phaser until it's the same magnitude, and then I take this phaser and I draw a line parallel to the other phaser, the same magnitude, and then I start at the origin and I draw a new phaser from the origin to where they intersect. That's this phaser plus this phaser. Notice I have a new angle and a new magnitude. If you look at this one, look what happens. This is going to end up being, yeah, that's weird. The thing is, here's my point though, is you don't have to do this. You can just use your calculator. So now let's add this up again, but let's put the complex numbers in. So let's go. I'm just going to type the numbers in. 21.34
Yep.
angle 39.8 plus 42.68 angle 39.8 plus 25.61 angle minus 140.2 plus 32 angle minus 50.2. So you should have, depending on rounding errors, I have 49.99 angle 0.001.
If you use the exact numbers.
Yeah.
Copy and paste, then get that piece.
Yeah, if you store them and add them, then you should get exactly 50. So if everyone could, okay, so you have the answer for this. This is an in-class activity, so so hopefully you got, I can put these calculations back up here. Take a picture of it if you have to. If you didn't keep up, just take a picture of it with your phone. This exercise is worth points. How many points? I didn't put it on here. Question? I didn't see number 3. I don't need this. Sorry, I forgot number 3. So we just did that. Now add the voltages from step 1 again, but add the entire complex numbers.
Oh,
So that's what we just did. The whole point behind this exercise was to get you to understand that you can't just add the magnitudes of the phasors. You have to take into account the angles too. And that's why we use a calculator or software to do that. So you should be able to complete this worksheet from the information I just gave you. So number 1 is all this stuff. Take a picture if you want. So that would be for part 1. That goes here. Part 2 is add these magnitudes up and then say it equals 121.63. So the answer to the question is, what is the total? And then it's 121.63. Does it equal the source voltage? No. Why or why not? Because you have to add the entire complex number to get the source. And then question number 3, now add the voltages, which I just did. What is the total voltage of all the phasors? It should be 50, 0 degrees. Does it equal the source voltage? Yes. Why or why not? Because we added all the complex numbers. So is there any questions about worksheet number 3? Hopefully you should be able to get it done and give it to me before you leave. If it's not done, just give it to me Tuesday. It is worth points. Let me look. Let's look in Blackboard. I forgot how many points it's worth. Wait a minute. You used to be able to tell by looking at the week 2, week 2A. Yeah, it's right here. Let's see. I'm not used to this new format, so let's
go to grade. Oh, yeah.
right here it is, 10 points. It's worth 10 points. So I just gave you the answer. Does anyone have questions about lab 1? So we didn't actually finish that spreadsheet. You want to look at that?
I believe we finished it, but I thought a few people just had problems.
Oh, okay. Yeah. So we can go over that if you need help with that. I think what I'm going to do with that lab is you can do the whole lab in Excel. You don't have to hook the circuit up.
Okay.
It's just very tedious. I wanted you to, I think maybe in another lab, I'll have you measure phase shift with the oscilloscope because you need to know how to do that.
Yep.
But for this lab, so let's look at the It's this one right here. And I have to fix this. Oh, you do have to answer the questions. And you do have to give me your data. So let's look at this. Let me know if you did not get this. That's the wrong one. Let me split this right up. So if you get that worksheet done, just put it in this file. If you don't have it done, give it to me Tuesday. I just gave you the answer, so all you have to do is fill it out.
Well, in regards to worksheet 1, I got -110.777.
Then you made a mistake.
Plus 79 points.
So last year I did this and it added up to 50. I just did it again and it added up to 50. And Blaine did it and it added up to 50
Which,
for the worksheet. What are you
that's
talking?
number 3, I'm talking about number 2. Where you just add the
Where you add the
where
magnet?
be front voltage, not the angle.
Yeah, it's just the whole point was just to show that it doesn't equal 50. I think I got 120 or something like that. Here, I'll do it again. Don't add the angles, add the magnitudes. What does it say? It says add the magnitudes of all the voltages. 21.34 plus 42.68 plus 25.61 plus 32 equals 121.63. So what's the question? This is the magnitude right here. This is the angle. Magnitude. Here, let's. Magnitude. Angle. So if I drew this on a complex coordinate plane, I would go 21.34 angle 39.8 degrees. So this is VL1. So what was I talking about? Oh, how many points it was worth. So as far as homework 3 and 4 goes, same deal. I just gave you the answers. All you have to do is fill it out and give it to me. And then the lab, that's what we were talking about. Why does that keep disappearing? I keep losing that. Get it. Let's do this. That file keeps disappearing. It's like Microsoft is pushing the cloud on everything.
So you want us to take captures of our data and graphs?
That is correct. Let me find. Maybe it's in. You're gonna have to find it this way. Lab 4 data. No, that's not it. Lab 1 demo. So this was from last Thursday. Maybe this is the one now. That one download. So let's go file, save as. I want to see where the hell this is. Ah, it's in advanced service. It's in here. Right there. Yeah, that was from 9/4. That was last week. So that's the one that we were working on. All right. So did everyone get to this point? Yeah, these two graphs.
0.47 and trying to.
Okay, so if you copy, so do you have this in this chart?
Yes.
So you have this
The one you got, yeah.
and you have this chart.
Yeah.
So now you can copy this one. Right click on it.
Yeah, I have it.
So you,
Started, I just don't have it.
okay, so then all you have to do with this one is you have to change the frequency range and you have to change the capacitor.
Okay, capacitor is.
So then I think you'll have 1,000 to 3,000. Now you have to go over here. I think I think I showed Ethan this. You just click here and insert some rows. And then go up here and type 500. Should I come and show you? Here, maybe this is what I'll do. I'll show you this way. Let's copy this one to the end. And I'll show it to you. Okay, so the first thing you have to do is you can go like this, insert some rows. Yeah, you click right here and you click on insert. Then let's get rid of this shading. So we go over here, right here. Go to no fill. And then type 500. Oh, we got to make this, we got to get rid of the bold. We got to go 500 to 2,000. I'm just going to call this one. So we got, and we want to go in steps of 100. So we're going to say, click right here, click equals this plus 100. Yeah, drag it down. So we want to go from 500 to 2,000. So drag it down to there. And then we want to change this to 0.47 E -6. So just type in 0.47 E -6. Enter. So that you got that so far? Okay, now click on this right here. Click on this first roll and drag across and copy it. Control C, hit Control C. And then put the cursor there and hit Control V. It'll auto index for you. Then escape. Then you can highlight across this, and then if you put the cursor here, it turns black. You see it? It's white. See the cursor? It turns black. Click on it and drag. And maybe just for good measure, click on this and drag it down to update all those cells. So did you get that?
We'll say the grade now. Correct.
Yeah. Click on the first one. Yeah, you can drag it all the way down. Click here and drag it all the way to the bottom. It'll update all the cells. All right, now we want to plot it. So we want to click on frequency down to 2000. Then hold the control key. Click on magnitude and go down.
You're also gonna want to change your VS to all being one again. Did the thing where it,
Oh, yeah. We got to do that. Because do you see what happened? It auto indexed this. So we got to type ones in here. Next time I do this, I'm just going to use an absolute reference to this cell. And I'm just going to get rid of that column. We don't need it. For some reason, I don't know why I put it in there, but whatever. It is what it is. So did you do that? Did you change VS to ones?
Yeah, I'm working on it.
Pardon?
It's already super simple.
Let me know once you get to this point.
I'm done. Yeah.
Okay, so now click on frequency and drag down. Left click, hold the button, drag down. Click on magnitude and drag down. You gotta hold the control key. So you do this, then hold the control key and do this. Now you want to go to insert right here. See it in the menu. Insert, and then go over here is scatter chart and use the one with points. Looks like oh, okay, yep. Then you can right click and say move chart, new sheet. You can go in here and edit it and put stuff in there if you want. Like on this one, you can say, what is this one? Output voltage, and this is frequency. So if you click on this and if you go quick layout, you see it right here. If you click on quick layout, find this one, the first one, you see there's axis titles. You can click on this and put it on the bottom. Format legend, bottom. I like it on the bottom better. So this is magnitude in volts. Hey, when Wade, when you came here last or earlier, was it because you didn't have multi-sim?
Yeah,
Yeah,
that
that's
was part of it, and then also just to take a mental break. It's
Oh.
like you feel crazy after a while, some of the things we're supposed to do.
Yeah.
It's like, it's nice to feel human, to talk to somebody who's in the same boat.
Yeah. I was talking to Robert. He's just like, I'm not doing this.
Yeah, so like the.
Well, you
whole-
guys are screwed because you have so many. You have like manuals, and then you have PowerPoints that have like 50 pages.
So I mean, if the goal this fall is to make our analyze scores better, I'm gonna wait till I'm done with my class. I'm gonna export my class, and then I'll delete everything that lowers my score, and I'll be like, there it is. And then when
And then put it back.
Well, I won't put it back, but when I rebuild for the spring, I'm just gonna do grades and testing. I'm not gonna put any lecture material there. I'm not gonna put any. I'll put homework there if it's not like worksheets and stuff
This
like
is
that.
this is what I did for this class. Okay, I have this. I have the textbook right here.
That's in the
Oh, yeah.
electrode under the student access.
Yeah.
Yeah.
I took it out of Blackboard. Okay, now
You
the
have to.
students can't access it when they're at home. So how is that helping? How is that making it more accessible?
But they could copy the whole thing and copy it over, but yeah, it's terrible.
Yeah, now before they could go into Blackboard and they could open up chapters up and read them. Even with their phone, they could do it. Now they can't.
I hate to overuse this. That the hell is paid with good intention, and there's all these good intention, but they're just driving straight to hell.
It seems like they hired WD.
Yeah.
For one specific purpose, as accessibility. It's because he has experience doing that for the city of
Right.
St. Paul or was it
Right.
Minneapolis?
It's
Yeah, he
not,
worked for the city and
it's not for tech company.
Yeah.
That's not recording, is it? Pull that back.
no, I think I said that. Ooh, it's recording. I'm gonna edit it.